In this video, we're going to be looking at topic 2H, chemical tests. Now, this content is specific to the double IGCSE science course for Edexcel. This content can come up in the triple exam, but mostly it is all double outcomes. There is a separate video for single students. Please feel free to check that out if you want to go through that. So the learning outcomes that we have for this topic are looking at how we carry out tests to identify gases, how we carry out flame tests and the sodium hydroxide test to identify specific cations, how we identify specific anions, specifically the halides, the sulfates and carbonates, and how we can test for water both chemically and physically. So we're going to start off with looking at how we test for gases. So the first gas that we need to know, you will have learned back in GCSE, which is hydrogen gas. And the test that we use for that is we take a lit splint and we put it into the gas and it should burn with a squeaky pop. You also get hydrogen and oxygen combining to form water, but because you can't actually see that, you would describe what you can hear. And the answer would be it burns with a squeaky pop, being specific that it is with a lit splint. For oxygen gas, again, you would have met this in Key Stage 3. We take a glowing splint this time. So we light a splint on fire, we blow it out, and then we put it into the suspected oxygen gas. And if it is, it will relight into a flame. Carbon dioxide gas, again, you learned at Key Stage 3, and it is as simple as it turns lime water cloudy. Now, the way that this reaction happens is lime water is calcium hydroxide. It reacts with the CO2 in order to form a precipitate of calcium carbonate and water. So because it forms a precipitate, we start to see this cloudy colour being formed. So you can see that it is clear and colourless at the start when it is the calcium hydroxide, and as we bubble the CO2 through, it will start to get more and more cloudy until eventually you cannot see through it anymore. This one is new for GCSE and it is how we test for chlorine gas. Chlorine gas will bleach red litmus paper or universal indicator paper to a white colour. So you can see that here we have our white colour. If we have blue litmus paper, we get it going red first and then white. So for blue litmus paper, it is just to red to white, whereas if it is simply red litmus paper, it just goes directly to white. We also may see a pale green gas because it is chlorine, but that is not a suitable chemical test. For all of these tests, it's not about just the observation of the gas itself, it is how can we chemically test that it is chlorine. If we have ammonia gas, this time we're looking at, again, the red litmus paper, and we're going to get a colour change to blue, telling us that this is a basic gas. Now we can look at how we test for water, and there are two different ways. The first way is a chemical test for water. And the chemical test is to take something called an anhydrous salt, in this case copper 2 sulfate. And anhydrous just means without water. We take this anhydrous salt and it is white when there is no water, and as soon as water is in the presence of this salt, it turns blue. So we see a very clear colour change from white to blue, and that is shown in this diagram here. So the anhydrous copper sulfate doesn't have what we call this water of crystallization, and that just means it's got water molecules attached. You don't need to know how, just that they are attached. So anhydrous does not have this, so it is a white colour. If it is hydrated, it has this water of crystallization. So you can see here, we have CuSO4 dot 5 5H2O. This is telling you there are 5 waters attached, and the colour is blue. You can also use things like cobalt chloride paper, and it will turn pink, but the most common chemical test for the testing of water is copper 2 sulfate. It's very important that you include the 2 as well, and you write it like that. We can then check for a physical test, because the water of crystallization test, or that chemical test we just looked at, will work on any substance that contains water. It does not, however, show if it is pure water. If we want to check for pure water, we have to carry out this physical test. And the way that we do it is we measure the melting point and the boiling point. And we do this at 1 atmospheric pressure. And if it is pure water, the melting point is exactly 0 and the boiling point is exactly 100. If it is impure, or there is anything that should not be there, you will freeze at a lower temperature and boil at a higher temperature. Now let's move on to how we test for cations. Just a reminder, cations are positive ions. So typically these are going to be your metals. And there are 2 different ways that we can do this. The first way is using a flame test. And we can use the flame test to detect very specific cations, because the majority of them will burn with very unique colours. There are some that do not have a colour, but you won't learn about them until you get to A level. So you don't need to worry about them for now. There are certain ones that you have to know that have a specific colour. So a typical question in an exam could ask you, how do you carry out a flame test? And that would be for 2 or possibly 3 marks. So the way that we do this is we take a platinum or a nichrome wire, making sure that it is clean. We dip it into concentrated hydrochloric acid, and then we dip it into the salt or the solid or the powder to be tested. We then take that wire with the solid on it and we place it into a roaring blue Bunsen flame, sometimes written as non-luminous. A luminous flame would be the one that you're probably used to seeing, which would be the orangey yellow flame that you get whenever you burn something. So for example, if you burn a candle, it gives off light. That's a luminous flame. A non-luminous flame is the blue flame that you get on a Bunsen burner, and it is extremely hot. The reason that we have to use the non-luminous flame is it allows us to see the colour. If it was a luminous flame or an orange flame, the colour would be masked by that orange flame. Okay, again, that's a very common exam question, so please make sure that you do remember that. So the colours that you have to know are red for lithium ions, yellow for sodium ions, lilac for potassium ions. Notice that it is lilac and not purple. They're very specific. It has to be lilac. An orange-red colour is for calcium, and a blue-green colour is for copper. Those are the 5 that you have to know. So please make sure that you do memorise what they look like and what the colours are. So there's another way that we can test for cations, and this is using sodium hydroxide solution. Now this is only possible for specific substances. Now for hydroxides, or any metal hydroxide, the only ones that are soluble are sodium, potassium, and ammonium. So that means that if we take any other metal hydroxide, they are going to be insoluble and they are going to form a precipitate. And that is a solid within a liquid. So this is where we take 2 liquids or 2 aqueous substances and we form a solid. Okay, and this is known as a precipitate. So the three that you have to know, and you can see the pictures here. So we've got copper 2. So as well as using a flame test, we can also use the sodium hydroxide test, and we get a blue precipitate, and it is because we form this copper hydroxide. So you can see here, you can see the blue solid floating. Iron 2 will give you a green precipitate because we make this iron 2 hydroxide and we get this green colour. And iron 3 ions are going to give us an orange or brown precipitate because we make iron 3 hydroxide. Notice that there are 2 different types of iron and 2 different colours. Please do not get them mixed up. This is very common for them to ask you in an exam, potentially in a multiple choice, and they may ask what is the colour of the precipitate for iron 2 hydroxide, and they will give you green and brown as one of the answers because they're trying to make sure that you can distinguish between the two. Now, sodium hydroxide solution can also be used to test for ammonium salts, but it does not do it by a precipitate. What it actually does this time is we form ammonia gas. So we add the sodium hydroxide to the ammonium salt and it breaks up and we make ammonia gas, and we then can test that gas and it turns our litmus paper blue, which we've already covered so far. So this one is just slightly different. Whenever you're talking about this test, you have to say the reagent that is added, which is the NaOH. You have to say the gas that is formed, which is NH3 or ammonia. And you have to say how you test for that, and that litmus paper turns blue. This is sometimes a 2 or a 3 mark question, depending on whether they ask you for the reagent at the start. So just to summarise, if you use the NaOH solution, you can either get your precipitates or you can get your gas being formed if it is for ammonium. And that's how you test for those cations. We run these tests on a specific salt or a specific solid, and we get one of these positive results. It tells us that that cation is present. So now we have to look at the anions, and remember, anions are negative ions. So the first one we're going to look at is the carbonate ion, which is CO3 2-. Where we start is we add dilute hydrochloric acid, and we should see fizzing, or sometimes written as effervescence. Okay, and that effervescence or fizzing that is being formed is carbon dioxide gas. Now, in an exam question, it is not enough to simply say, look for fizzing. You must say this part, and that the gas is carbon dioxide, and we can confirm that the gas is carbon dioxide because it turns lime water cloudy. This is likely to be a 3 mark question. Again, it'll ask the reagent, in this case HCl. It will ask the gas, CO2, and it will ask the test, that lime water goes cloudy. So important that you have each of those 3 points. They may ask you for the ionic equation. It's unlikely, but just make sure that you do know how we do form this gas. So another anion that we need to be able to test for is the sulfate ion, which is SO4 2-, and we require 2 reagents here. The first one is nitric acid, and then we follow it by adding barium chloride. And again, we're looking for a precipitate here. And the precipitate that forms is this one here, barium sulfate. And you can see this is what it looks like here. This is a positive test for a sulfate ion. Now, the reason that we add the acid is to react with any carbonate impurities, because if we have carbonates present and we form barium carbonate, that is going to give us a false positive, and we don't want that, because that's telling us that potentially there's a sulfate there when it's actually not. So by adding the acid, we're going to create the carbon dioxide, similar to what we've just seen in the previous test, to get rid of all those carbonate impurities, and then we add the barium chloride. Again, very common exam question. And the last anions that we have to understand how we test for is to test for the halide ions. And it is only for chloride, bromide, and iodide. And the way that we do this, again, we add dilute nitric acid just to get rid of any impurities, and then we add silver nitrate. If there's any carbonates or sulfates in there, they would give us positive results that we don't want, so we want to get rid of them. And we have 3 different colours that will form depending on which ion we have present. So if we have chloride ions, they will react with the silver to form silver chloride, and that is white in colour. If we have bromide ions, they will form silver bromide, and that is cream in colour. And if we have iodide, it will form silver iodide, and we get this yellow precipitate. So this is a precipitate of silver chloride, this one is silver bromide, and this one is silver iodide. The only problem with this test, as you can see, is they do look quite similar, so it can be quite difficult to distinguish between them, but the yellow is very clear that it is yellow. It is just the chloride and the bromide with the white and cream sometimes can look quite similar. So just to summarise, there's our tests for each of our anions that we have to know. So we need to know our carbonates, our sulfates, chloride, bromide, and iodide. So let's have a look at a past paper question. We're going to start off with looking at the June 2017 paper. So a student is given a mixture of 2 solid ionic compounds, A and B. Each of them contains 1 cation and 1 anion. Compound A is insoluble and compound B is soluble. For 2 marks, describe how the student could separate the mixture in order to obtain solid A and a solution of B. Some people may overthink this question, but it is actually just as simple as you think. How do we make any solution? Well, we add water to the mixture and we stir. And that will give us our solution of B, but it will also give us our solid A in our mixture, and we want to remove that. And going back to the beginning of GCSE, where you looked at topic 1B, elements, compounds, and mixtures, how do we separate an insoluble solid from a liquid? We then filter to remove solid A. 1 mark for adding water, 1 mark for filter. So the table shows the results of 2 tests that the student does on a solution of B. And the first test is that we have we add the sodium hydroxide in warm, and we get a gas that turns litmus paper blue. Our second test is we add silver nitrate and dilute nitric acid, and we get a white precipitate, and our precipitate does not dissolve. So we want to use the information to identify the cation and the anion. Well, test number 1 is our cation. Test number 2 is our anion. So what cation will form a gas that turns litmus paper blue? It can only be 1, which is ammonium, which is NH4+. Notice that you must have the charge. If you do not write the charge, you do not get the mark. Also, if you write the formula and the name, you must get both of them correct. So if you can't remember ammonium's formula, just write the name. If you write both, you have to have them both correct. And for our anion, it's the silver nitrate test, so we know that that's going to be one of the halides. And we have a white precipitate forming, so that tells us it is the chloride anion, or Cl-. And then the gas that is given off in test 1 that turns the litmus paper blue is NH3 this time, which is ammonia. Please make sure that you do distinguish between ammonium and ammonia. The student adds dilute hydrochloric acid into solid A, and then we get a gas that is turning lime water milky being given off, and we have to explain which anion is present in solid A. Well, the gas that's being given off is carbon dioxide, and the anion that is linked to carbon dioxide is going to be the carbonate ion. So we know that a carbonate ion, or CO3 2- is present because, so remember it is an explain question, so we should be saying because carbon dioxide gas is given off when acid is added. Okay, and that's for 2 marks. Note that what we said before, we have the reagent, the gas that's being given off, and the test. We have all of that information in either the question or in the answer. And then part 2, give a test to show that solid A contains calcium ions. Well, for any metal, the most common test is going to be your flame test. Notice that it doesn't say explain, it just says name. So flame test is an acceptable answer, and then the result is you will get an orange, red flame colour for 2 marks. So there's our mark scheme if you want to have a look at those, if you've been working on those questions yourself. And let's just have a look at the January 2012 paper, just to go through a very common question that comes up in exams, where compound X gives us a blue-green colour in a flame test. Describe or outline how you would carry out a flame test for 2 marks. So how do we do this? Well, the first part is we take a clean platinum wire dipped in concentrated hydrochloric acid and then the solid, and we add it, or we then put the wire into a non-luminous or blue Bunsen flame. And then we will, of course, observe the colour. And that is for 2 marks. Now, sometimes you may see in mark schemes that they do not require you to mention the concentrated hydrochloric acid. However, I would always recommend putting it in your answer because it shows that your answer is nice and full, and you do come back to flame tests in A level. So if you get the explanation perfect at GCSE, it just makes it that little bit easier when you go up to the next level. So we can see that we get the mark for our wire or our glass or our silica rod, in this case ignoring the references to hydrochloric acid, and then we have our non-luminous or blue Bunsen flame for the 2nd mark. That's everything on chemical tests for the IGCSE chemistry course. If there's anything you're not sure about, please feel free to leave a comment below, and we hope to see you back on the channel in the future for other revision videos.